All right, cool. I hope everyone can hear me out there. Yes, I'm Sune from the University of Copenhagen, a philosopher by training and trade. So I don't have all the technical insights that we just heard about, but I think Leo's talk just before actually sets the scene quite well for the approach that I will take to the use of these AI systems in medicine and elsewhere. I think many of the ethical issues are sort of general for other domains of application than just the medical field. The sort of keyword for the way I have set up the presentation today is accountability. I think just to begin, I'll just say that what I will have in mind when I will be discussing today is what I'll think about as algorithmic decision making. So we have algorithmic decision making in the sense that I will understand it when an entity, say a doctor or bank manager or whoever uses an algorithmic system needs to make some decision, and the decision maker defers to the output of the automated system. So this might be the case that I'm also referring to later on of having an AI system that basically makes screening decisions about whether to send people or refer diabetic patients to an eye specialist for diabetic retinopathy. As you will see, that's actually set up as making decisions in situations where we don't have expertise to make the decisions. So in that case, the deference of the decision is quite genuine, real. It is the computer system that will make the referral decision, in fact. But this is what I have in mind when I talk about algorithmic decision making. And what I will focus on is when is it justified to use an algorithmic decision making system in some context? When should the people who are subjected to the decisions accept them? And what is required for accountability in the relevant sense in these contexts? As Leo also mentioned, and I think some of the questions that were raised also had in the background, is that when you mention the notion of accountability, focus very quickly is on so-called what I will call black box concerns. We don't know or understand the models, the predictive models that have been trained using, in this case, usually supervised learning. That's the background idea that I have for these systems. It's impossible for humans to comprehend the mechanism, the inner logic, as I think the EU white paper calls it, of the system. Basically, they are just too complex for us to walk through the steps of calculations that are taking place. And that's usually translated into a worry that the algorithmic decision maker can't explain the decisions or the output of the system they use. And apparently this also threatens the accountability of the decision maker. So in this case, accountability is very much tied up with an ability to explain the algorithmic mechanism that leads to the output. Now, I'm not going to argue that that's not relevant for algorithmic accountability, but I think it's just one part of the problem about accountability. I think it's just one aspect of what we need to discuss when we discuss accountability. Now, just to sort of move a little bit on with the black box concern, Zachary Lipton, who is quite critical about the whole movement towards making interpretable algorithms, simply because he thinks that the notion of interpretability is very vague. But he says, he has this nice quote that I thought I'd bring to the table today, because the whole movement towards increased explainability or interpretability it might be justified in the way that he suggests here. We can train a model and it can give even us give us the right answer, but we can't just tell the doctor or the algorithmic decision maker, my neural network says this patient has cancer. The doctor just won't accept that. They want to know why the neural network says what it says. They want an explanation. They need interpretable models. So what this suggests is that those users of medical AI who are concerned about being able to account for the decisions that they are making, they think it's crucial that they can explain the mechanism. Now, much of the work that tends to go on with respect to making interpretable models is to have these sort of models where you show how much various features impact the output, or it could be that you highlight certain areas in the picture or whatever. Now, I think these are all very good ways of trying to make sense of the output to human beings, but I don't, and this is just sort of a claim that I will make, but I think Leo actually said something similar. It doesn't make humans understand the model mechanism. I mean, that is incomprehensible to humans, but we might make further models that models in a way that we can make sense of what goes on in the algorithm, right? At least that's how I understand or see the many ways that scientists and machine learning programmers are trying to make their complex models explainable. But I think that's even when that has a value for the user or the subjects of algorithmic decisions, that we have these models of the way that the algorithm makes its decision. I think there are many other issues that are relevant for actually accounting for the use of a medical AI. So what is it to be accountable? Well, you know, I read up on various theories, both in social science and in philosophy and so on accountability. And the notion of accountability is sort of a notion that is thrown around quite a bit. It is used in many contexts and so on. So I'm not going to argue that I have the right notion of accountability here. This is just a way of clarifying my terminology, so at least we know what I'm aiming to talk about. So in the way I will use the term, an accountable decision maker must provide stakeholders with a justification for the design and operation of the algorithmic system being used. Now, of course, part of this has to do with the type of model being used. Why are you using a neural network and not some simple linear model for this task? That seems to be a sensible question to ask the designer about the way they have designed an artifact for a certain purpose, namely making decisions about some medical condition or not. So in that sense, whether or not to use a black box model is a relevant consideration as part of making the justification for the design and operation. But there's also another notion that I would like to throw in, because why is accountability important in this sense? What is it that we want accountability for? Well, I think there's sort of a higher purpose for why we want accountability when we are having these decision-making processes that make quite important decisions about people. And that is, we want the decisions to be legitimate. And what do I mean by legitimacy here? Well, a decision in the sense that I'm using it here is legitimate when it should be accepted by reasonable, I'm not going to go into details about what that would include, but that's a big philosophical issue, of course, but when they should be accepted by reasonable stakeholders, regardless of whether they are correct. Compare this idea to the legitimacy of the verdicts of a trial. A trial is a process or procedure that is used in order to determine whether the accused, say a criminal trial, whether the accused or the defendant has, has done the thing that they are accused of doing or not. And it's done on the basis of evidence, of course, but there are also a lot of rules for how the trial should proceed. And why do we have all these rules that are supposed to make the trial fair? That's because it entails that even when they get it wrong, it's still an outcome that should be acceptable to all stakeholders, including just ordinary citizens who care about the way the society works, right? Take another case in a democracy, like you know, when you have a parliament passing laws and so on. I might not disagree with every single law that the parliament passes in Denmark, but I accept them because they are the procedure that leads to the decision to pass that law is one that I take to satisfy certain conditions, constraints, and so on. So that's the notion of legitimacy that I think it's worthwhile applying to the case where we make important decisions about people too in medicine, using a procedure, which is now, that's why we're sitting here today, in some cases, a procedure that involves an algorithm making a prediction about whether or not the patient has some condition or not, on the basis of being trained on evidence and all the rest of it that Leo just mentioned. And I think accountability is important because it's central for the decisions of a procedure to be legitimate, that we can hold those procedures accountable, or the users of those procedures accountable. That's one way of achieving the acceptability of the decisions, even when we disagree, even when they're incorrect. And here, by an incorrect decision, I mean one that turns out to be based on a false prediction. So the patient didn't have the condition, even though we treated him or her as if she did. This was some terminological background that sort of is in the back of mind. So I also picked up on this FDA or the IDX-DR algorithm, partly because it apparently is the first algorithm that was approved for market use. So I thought, well, I'll just use that as an example. But of course, there are quite a few medical AIs out there which are already making their way into clinical practice. But this is the case that I'm just going to have in the back of my mind. But it's also sort of an alibi for saying I'm talking about medical AI. I think all the considerations I'm presenting now could be used also in other contexts, as I mentioned, whether in criminal justice or in hiring people or education or what have you. So the IDX-DR, this is how it's presented in the press release when it was approved for marketing. A doctor uploads the digital images of the patient's retinas to a cloud server on which IDX-DR software is installed. That's the algorithmic system. If the images are of sufficient quality, the software provides the doctor with one of two results. So this is a binary classification that's used to make a binary decision. Either the patient is classified as having more than mild diabetic retinopathy, and the decision that, or the recommendation that the algorithm will put out is referred to an eye care professional. Or the system recommends that, or predicts that the person is negative for mild diabetic retinopathy, and the system recommends rescreening in 12 months. And now the whole idea, or at least part of the justification for using this system, is that it can be used by people who have no clue how to detect retinopathy. So your local practitioner who might not have any, I mean, it's a highly specialized skill to look at these images and see whether or not the person suffers retinopathy that's more than mild. But with these sorts of systems, you can go to your local practitioner. All they need is a camera that can take these images, and then they can ship them back to the computer program, which in 20 minutes or so will give the doctor this recommendation. Now, what's striking is that it's still supposed to support the doctor in making the decision. It's not saying that this is the system, that is the system that makes the decision. It's decision support. But I think in this case, it's quite clear that if a doctor is asked, say, by the National Health Services to use the system to screen for retinopathy in diabetic patients, then they're just going to do it and sort of defer the decision completely to the system, unless something completely crazy happens in the situation. Maybe the patient comes in and is completely green. They think something's really wrong here. It's not just diabetic retinopathy that's being detected. Something more has to be done. In any case, but I think this is why when I'm talking about the algorithmic decision maker, I'm basically thinking in terms of whoever has the authority to determine that this system is to be used. So in this case, it might not be the individual practitioner. They might actually be asked in a polite but firm way by the National Health Services to implement this system in their practice, right? So in a way, you might say there are several stakeholders here which would be interested in being able to holding the algorithmic system accountable. The doctors who are asked to use it might also think that it's important that they can hold accountable those who ask them to use it for why should I use this system? How do you justify using the system? So coming back to this notion of accountability as something that involves justification of the operation and design of the system, what should such a justification include in addition to, say, considerations about the complexity or the interpretability of the model? Now, I think coming back to this idea that these are artifacts, it's like you might as well take a lawnmower. You can make an instrument that will help you mow lawns in many ways. There are very complex ones. My neighbors tend to have sort of autonomous ones that are driving around cutting the grass. I've moved from one of those where you push it yourself, the manual ones, to one that has an electrified engine in it of sorts. These are all very different designs and ways of operating a lawnmower. And I'm not only thinking about how well it mows the lawn when I buy a lawnmower, I also think about other constraints that I might put down on the way it's made. For instance, how much noise it makes, or how reliable it is, or whether I can actually steer it the way I want to, or whether it fits the purpose of mowing the grass in my lawn, which might be mostly moss and not so much grass, and what have you. So whenever we are talking about justification for using an artifact in general, we will ask for the purpose of the artifact. Is the purpose of this artifact justified? Should we accept it? Now, mowing lawns is generally an acceptable purpose to have when you produce an artifact, a machine of sorts. And trying to prevent blindness in diabetic patients is also usually thought, I think, as a valuable goal when you create a decision procedure for practitioners who are making screening decisions. So in general, there is, of course, most people say a really valuable goal here that's being aimed at with this system, namely to prevent blindness from diabetic retinopathy. But of course, there are different ways that you might interpret this goal when you actually make the system. And I think that's where the justificatory element comes in again in terms of the design of the system. How exactly is it that you are going to design the system to prevent blindness? Are you going to design the system to be to increase efficiency of preventing blindness? That might have consequences for who it is that it actually thinks it's how you tune the system. Then you probably go for some sort of accuracy optimization, just to make sure that as many as possible who will suffer diabetic retinopathy are being referred, and vice versa, those who don't won't be referred. But you might also think, no, well, actually this system is not just aiming at the most efficient use of our eye specialist resources to prevent blindness. No, it's also aiming at the most fair use of the resources that we have. Now, this will require other considerations than just optimizing the system for accuracy, and I'll come back to it. But the notion of fairness in terms of how the system's classification and recommendation is distributed, say, across groups of various kinds, salient social groups like gender or race or age groups and so on, will be relevant for this sort of consideration. And that consideration might actually constrain you with respect to achieving as much accuracy as you could if you just didn't care about fairness and the distribution of resources. Again, this is the sort of consideration that I would suspect would go into a justification for using the system, is to clarify this question. I'm not saying that you should do one or the other. I think the point here is actually about transparency, about making clear what sort of justification the user finds to be sufficient or adequate for using the system for the purpose at hand. Now, there are much more specific issues that will come up when it comes to justifying the design and operation of the algorithm. So again, what type of model is used? That's the black box issue we already talked about. But there's also an issue about the relative utility of false negatives and false positives. How should you weigh for instance, this retinopathy detecting system, how many false positives should you accept with relative to the number of false negatives? Of course, you can make sure that every single patient who has diabetic retinopathy is referred to a specialist. You just ask the algorithm to refer everyone. You can easily, I think you can easily make an algorithm. You might not even need an algorithm system to do that, right? But of course, the point about the algorithm is usually that you can somehow move the bar a little bit down. So not everyone is referred, but only those who are very or sufficiently likely to be referred are referred. That's the whole point of making a predictive algorithm, is to assess the probability that the patient actually has this condition. But when do you move so far down that you get too many false negatives? That's an important decision, because this is where you actually get the impact on people, right? that is not written in stone or in the sky or anywhere else where you should set the bar for the relative importance of false negatives and false positives. But what I think is quite common amongst those making machine learning algorithms of this kind is that they assume, just to get started, that a false negative and a false positive has the same negative value, right? Has the same cost to whoever we're caring about. Of course, that's another question about the cost of a false negative and a false positive. The cost of sending a patient to the specialist when they don't suffer retinopathy, and the cost of not sending a patient to the eye specialist when they do have retinopathy. Is it only the cost to the individual patient, or is it also the cost to their family that's relevant here? What if they have a job where it's really important that they can see? And if they lose sight or the sight is diminished, then this might cost a lot of people their job. I don't know, but maybe they're radiologists who actually save people's lives because they're very good at looking at images. The cost of a radiologist suffering a false negative from IDX-DR might be calculated to be higher than if I did. I'm just a philosopher. Yeah. I think we get into very complex issues, and the thing is, we can't neglect that these considerations will be, at least you can say, any design of an algorithm like this will reflect considerations like this. They might not have been explicit when the algorithm was designed, but when you look at it, it will actually have an impact on these things, and some sort of value will be assumed. Furthermore, decision thresholds, similar issue, and then of course also how fairness is understood. And by fairness here I mean, how well does the system perform with respect to socially salient groups? Some of you might have heard about the system in the US, which sort of kickstarted this whole debate about algorithmic fairness. They used, it's probably still in use, an algorithm used in the criminal justice system in the US called Compass. And there was a sort of analysis of the way it performed on some in use in a county in Florida. And it turned out that the false positive rate was twice as high for African-American defendants as compared to white defendants, meaning that African-American defendants who were actually not at high risk of reoffending if released before their trial, they were twice as likely to be detained as white defendants who would not be reoffending if released before their trial. So the cost of using this system was much higher for the African-American defendants than the white defendants. That kickstarted a whole debate because it turned out that it's very difficult to actually ensure that these sorts of groups will be equally affected by this sort of algorithmic system. I'm not going to go into details about this just now, but just mentioning. And so this was sort of operation and design. There's also an issue about the performance of the algorithm. We would usually test and try to figure out how well does this algorithm perform before we start using it. And in the paper that was published in 2018, which allegedly led to the approval of the IDX-DR system, they show that it has very high sensitivity and specificity. So it's actually very good at finding, given that you have retinopathy, it's very good at identifying you. And given that you don't have retinopathy, it's also very good at predicting that. What they didn't really say much about was the predictive values of the system. It's actually not even accessible in the article what the predictive values were. I'm not going into the details of this because it's so, but there's a difference between whether you consider how well the algorithm is at finding someone given that they have the condition you're interested in, and assessing how well it is at, when it has produced a prediction, that prediction actually being in accordance with the truth. This is for further study, but that's the difference between predictive values and sensitivity and error and specificity. What a lot of people actually would think was important is that the performance also is shown with respect to different groups. They don't show that. They just say that it's pretty good across race groups, for instance, but there isn't any performance table documenting how well it does for genders, with respect to race, with respect to age, and so on and so forth. That would be obviously something that you would want information about if you were trying to justify the use of the system in light of fairness considerations, right? And then some of the other things that you also mentioned, Leo, so has the system been clinically validated, and what sort of training and test data were used? Can we count on this system being generalizable to you know, if it's been developed in Odense at Odense University Hospital, can we use it in Copenhagen and expect it to perform as well? Or are there things that we should be considering here in terms of who has it been trained on and tested on? All right. So I'm just going to, because this is the last point here, I'm just going to use and say a little bit more about the fairness and risk of misclassification, because I think this is a really nice illustration of what I want to say about accountability today, that to account for the use of an algorithm involves also considering what you might say non-technical issues, but ethical issues, because these systems will be designed and the design will reflect certain ethical values, whether you want them to or not. And fairness is a good one to use to illustrate this. So the thing is that it has been shown, I think it was actually shown many years ago, but it's sort of been re-shown by machine learning scientists, that if, say, two race groups, or let's talk about men and women, even though that's also controversial these days. But let's just assume that we can divide at least some of the population into men and women. Now, I think maybe women has a higher risk of retinopathy. The prevalence of what do you call it? Diabetic retinopathy is higher amongst women than men, female diabetics than male diabetics, but I can't recall exactly, but let's assume that that's the case. In that case, when the prevalence of the condition you're trying to predict is higher in one group than in another, it's impossible to achieve equal risk of misclassification for those two groups along all four ways of thinking about this. That's sensitivity, specificity, but also precision and negative predictive value. Even though it seems reasonable to want the algorithm to have equality across these groups on all four ways of measuring its performance. But it's just mathematically the case that you can't do that if they have different base rates or prevalence of the condition you're trying to predict. You can actually only achieve two of them. Now, what in the Compass case about fairness, what those who had made the algorithm said made it fair was that it actually was equally precise, if you look at this, with respect to all individuals that it predicted, made predictions about, regardless of what group they belong to. If you are a woman, so in that case, if you're a woman and the algorithm predicts that you have retinopathy, the probability that you actually do have it is the same as if it's a man that it makes a positive prediction about. However, in that case, it's very likely that given that you have retinopathy, there's a higher risk that you don't get caught by the algorithm than if you're a man who has retinopathy. It depends on how you actually read how you conditionalize the probabilities here. Now, given that this is the case, there is a huge debate about how should you actually design a fair algorithm. Because given that you can't have all you want, you have to make a choice. And I think the jury is still out on how to design a fair algorithm. But this is the sort of consideration that will crop up every single time we want to use a medical AI is, okay, how does it perform across these socially salient groups? Which groups should we care about? How big discrepancy is acceptable? And so on and so forth. And that's not just a technical issue either about fixing the numbers, so to speak. The reason why these numbers are important is that they are actually indicative of the costs of using the system to these different groups. And as you also mentioned, these systems will usually be used on millions of people. It's not just one doctor who might be a little worse at detecting retinopathy in women than in men or whatever. No, this might be used every day on millions of people. So the consequences in terms of equality of the impact of using this system might be very different from one group to another. So I think this is not just a matter of getting the numbers. All right, a few concluding remarks. So my suggestion is that accountability and legitimacy requires the availability of a justification for using AI. I think that's the key notion actually when we talk about these issues. What is it that a justification should consist of? Well, I've mentioned some of the things that I think should enter into it, but again, context will matter here too. Some issues might be more relevant in some contexts than others. So I don't think we have just a general checklist that you can say, okay, now we have a justification. If we can say why, or give reasons for why we have chosen this, that, and the other, that might be different from one area to another. But the importance about making these justifications available with the use of the system is that it exposes the decision makers to scrutiny. It's important because that's the only way that the subjects of the decisions can challenge them. Of course, different stakeholders will challenge them in different ways. And finally, I don't know where this is going to go because, of course, there will be many disagreements about this. And I'm not saying that a justification must consist of non-objectionable claims. It will probably consist of objectionable claims. But some sort of ongoing discussion is necessary. And I think if that discussion is made possible, in particular by making all this information available, then there might develop some norms within different domains about what a reasonable justification actually amounts to. Okay, thank you very much.